And what? I can't hear you.
Atomic radius?
Atomic radius, thank you. Atomic radius, okay. And we know this is 0.7 down here. This is cesium. And we know that that's francium. I'm sorry, fluorine, correct? Now, what is the atomic radius of fluorine? What's the atomic radius of fluorine? What is it? 133? That's the atomic radius of fluorine. Is that right?
62.
Yeah, I think you guys are you reading the numbers correctly?
Oh, no, that's ionic. Right.
What's the, yeah, it's 62. Okay? 133 is the ionic radius. So 62. Okay, this is fluorine, okay? What's the atomic radius for cesium? 273. Just based on the actual distance, which electrons, which is going to have a greater attraction for the electrons? Why am I saying atomic radius is significant? What is atomic radius? What is atomic radius? The distance between the nucleus and the... Who said that? Excellent. Valence shell, right? Isn't it? Are you guys working today or what? Is Baslin and Kennedy the only people that are working? Can everybody pay attention? Look, let me tell you something. The better you participate, the better this video is going to be. The better the video is, the better it can be used as a tool to study. Clear? I can't do this. How many people have noticed that I give very little information? Don't I ask you questions? And the fewer people respond, the less diverse the answers are. Isn't that correct? So can we give answers? Shall I give you a grade for participation every period? No. So we're going to pay attention and we're going to participate. Right there, Mr. Z? Yes? Z-Man? Excellent. Okay. I have a grandson called, we call him Z-Man. Okay? I'm going to call you Z-Man. Is that all right?
Okay.
Excellent. All right. So, let me ask you again. Why am I talking about atomic radius? Who cares? Where is the bonding going to happen? The valence shell. So here's an atom. Here's an atom. Here's an atom. Right? Right? Watch what touches. Yes? The center of my fist is what? The nucleus, right? What's this called? Valence shell. Watch. So the distance between the nucleus and the valence shell, is that significant in terms of bonding? Is it? All right, when I do this, watch. What am I hitting my head with? I'm hitting my head with what? What am I hitting my head with? What am I hitting my head with? Right? I'm hitting my head with? What am I hitting my head with? I'm hitting my head with electrons, and just FYI, that's the mass of an electron. 1.7 times 10 to the negative 31 kilograms. Okay? Pretty amazing, isn't it? So is bonding a significant topic to talk about? It is. Okay, good. Now, so, right, okay. So 62, and are you close to the octet? Let's talk about ionization energy now. What's the ionization energy of fluorine? Look it up. You have tons of data. What's the ionization energy of fluorine?
153.
No, that's the ionic radius. I want to know the first ionization energy of fluorine. You have three sources for this. You can either use your textbook or the lab. And on the lab, you have two data tables. Go on, guys. What is it? 1681. 1681. And what's the ionization energy of francium? I'm sorry, cesium. What is it?
590.
What is it?
590.
519? 590? Okay. Okay. Red circle is ionization energy. Black circle is radius. So that's the distance. So what does that rather large ionization energy indicate? An almost filled what? Valence, right? Doesn't it? Yes? Remember, as you go from left to right, what happens to the ionization energy as I get closer and closer to the noble gas configuration? What happens? It increases, doesn't it? Yes or no? Yes or no?
Yes.
Excellent. You get it? Okay, let's look at another one. Let's look at oxygen. Oxygen is 3.5, right? Is that right? I've got to get out more. I remember that. What's chlorine? 3, right? Electronegativity. Chlorine is 3. Oxygen is 3.5. Okay, let's do it with one more. What is the atomic radius of oxygen? What is it? 66. Okay. What is the atomic radius of chlorine? What is it? 102? Okay, good. Good. Now, what is the ionization energy of oxygen?
1
What is it?
1
3. What? Say it again. All right, hold it. I feel like I'm in like the Grand Canyon listening to echoes. Okay, one person. Z-Man. What are you looking at that for? Can you do it? Are you with me? Anybody with me? Laura. 1314. Excellent. So this is 1314, which should make sense. If that's 1681, and so it should increase as you go from left to right, correct? Now, chlorine. What's the ionization energy of chlorine?
1256.
Basil.
1256.
1256. Okay, good. So, what is going to trump what? What's more important, atomic radius or ionization energy when talking about the influences of electronegativity? What's more important? Atomic radius is more important. Who said that? Kennedy, you're wonderful. Excellent. Excellent. Alex, are you with me? Look a little tired, look a little confused. You okay? You good? Why is Kennedy saying, Alex, that atomic radius is more important? Yes.
Because the atomic radius gives you the ability to attract.
What is also okay, but what is also higher? What is also higher with a smaller electronegativity though? Take out your graphs. How many people are finished your graphs? Look at your ionization energy graphs. Take them out. Take them out. Go on, go get them. Take out the graphs. Open the graphs. Okay, don't all move at once. You know that you're recovering from some kind of trauma. I know that everyone's very slow today. Is everybody back from, I think you need to do some more physical therapy. Laura, you okay? Everyone's a little lackluster today. So what do you got? Look at your graphs. I'm going to go off camera here for a second. Look at this graph. Look, isn't it wonderful? Oh my God. Look at this graph. May I? May I? Okay. Look at the graphs. What do you see on your graphs? Somebody talk to me. Laura, are you with us? Talk to me what you see. What do you see? Like look at period 2 and 3. Okay? Look at beryllium, lithium, beryllium, boron, carbon, that period 2. Look at period 2 on the graph and look at period 3. What do you notice? What do you notice? As I go from left to right, what do you see? Can you see that? Does that come up?
No,
It doesn't come up?
not at all.
Does that come up?
Maybe a bit more.
Maybe a bit more? Not much?
Not much.
Okay. What do you see? What do you see? Does everybody see this? What do you see? What do you see? Is the ionization energy increasing or decreasing as I go from period 2 to 3 to 4 to 5? It's decreasing, isn't it? So a smaller atomic radius is going to give you what kind of ionization energy, Alex? Larger or smaller? Smaller, very good, excellent. So, not only, see, look at this. So, the atomic radius is very important because it's closer to that what? Nuclear charge, yes? So, is the shielding effect important? It is important. Why is it important? Why is the shielding effect important? Why is it important? Why is this dropping from 1681 to 1256? Why is it dropping? Why?
Because you have more cells.
Why is it dropping 1681 to 1256? Why is it dropping? Yes?
Because you have more shells.
Yeah, more shells. The shielding effect. Yes or no? The shielding effect. That's why it's dropping. So the shielding effect is really very important, isn't it? Yes or no?
Yes.
Absolutely. So look at what happens. So the electronegativity goes from 4 to 3 with that drop in one period, yet going from left to right, it goes, and they're right next to each other, aren't they? So this is 3.5 to 4, isn't it? Very close. Same period, very close. What's happening to the atomic radius as I go from left to right? It's decreasing. That's why fluorine has a higher electronegativity than oxygen, right? Because fluorine is closer, isn't it? And how do you know, and why is the ionization energy here higher than here? Close to the valence shell of the noble gas, right? Or the O word. No, not the O word. Okay, are we done? Are we finished? Let's have some fun, okay? We're off. Go get goggles.